Alrighty guys, Day Daddy here, and as always, I just want to start by saying thank you for taking interest in my channel, and I really hope my content is useful for you. If it is, I really wish you guys would hit that like and subscribe button so I can continue to grow and provide more quality content. Also, if you really enjoy the content, you might even consider buying me a coffee, and the information for that is in the link in the video description below. So, anyway, let's get down to business. This is the second video in the Scapy series, and today we're going to be taking a look at some commands on the command line. And without further ado, let's hop in. All right. So first things first, I just want to pull up a couple things here. So we're going to pull up the commands. These are the same commands I used in the last video. I just kind of consolidated them into a little text file. Second thing we're going to need is we're going to need a terminal. So let's grab one of those. And then finally, I want to go ahead and, before we get too hot and heavy here, I want to go ahead and use Wireshark and get that going. So I'll just make it a little bit better to visualize the packets that we're going to be sending today. So we'll get that going. Let's go ahead and kind of make everything bigger so we can see it. Alright, cool. So we'll go ahead and open up the Wi-Fi interface. Alright, cool. So there we go. So the first thing we need to do here is we need to actually install Scapy. So let me go ahead and pull that up. I have the exact commands written down because it gets a little bit confusing. So here we go. Alright, so I know this command's not going to work for me. It may work for some of you guys. If you're using a Linux machine, it probably will. So pip install -- pre. So there we go. So this is going to install Scapy and some other auxiliary packages that help with some of the visualizations in Scapy. So you don't need to do this, but it's nice to have all this stuff. So again, if you're on Linux, I know that it works. It may work on Windows. It does definitely not work on Mac. So just to show, okay, doesn't work. So what you can do, or what we will do, is we're just going to pip install Scapy, and boom. And as I said before, Scapy is really just a Python library, so that's why we're able to install it with pip. There's other ways to install it, but basically it's built on Python, so we can use the Python package manager pip and go ahead and grab it. Just in case you're interested, I'm going to go ahead and pull up the Scapy docs here. And we are going to go ahead and take a look at this download and installation part. And I just want to show you, so there's pip install Scapy, pip install Scapy basic, and complete. So they just install other auxiliary packages, and if you scroll down, you can see, okay, one of the dependencies is matplotlib, which I've already got installed. This other one is pip install Pikes, or however you want to pronounce that, PYX. Let's say graphic, like a visualization tool in Python, VPython. There's a cryptography package that's installed. So just some auxiliary things, right, that are needed, or that will be needed later to improve some of the visualizations here in Python, or with Scapy. So the only other thing I want to tell you guys is, if you are interested in using the more advanced visualization functionalities in Scapy, you will need to go here, and this is mictex.org/packages/Python. You can go to download. So I guess really just go to mictex.org/download and grab, whatever your OS is, but grab that. For Mac, it was only about 60.6 megabytes, which was way better than the other version. So you could either get LiveTex or mictex, and this was like, the other one was like 4 gigs. So I thought this was a much better option. Basically, download it, install it, and then at least on Mac, you had to open the app and do a couple other things like software update, and then enable some features, and then it will integrate with Scapy, and you can use the visualization features in Scapy. So just a heads up on that. Okay, so now we have Scapy installed. Let's go ahead, and so when you open Scapy in a particular directory, that's where it's going to be able to access the PCAPs, and it's going to save any captures that you do. So I just like to know what directory I'm in before I start Scapy. So I just created a Scapy folder on my desktop. So there we go, and now we're going to start Scapy. Also, as a note, up here in the top, if you see another warning up here, it's probably because you haven't gone through and installed those extra packages. Again, you don't need them, but if you want the extra visualization functionality, you will have to go through and make sure you don't have those warnings anymore before it'll work. Okay, without further ado, so we're going to start with general commands, and the most important command I've found is this lsc command, and this lists all of the commands that Scapy has available. And again, tons of different commands. We're going to be going through, I mean, not even half of these, but Hex Dump, ls. In a later video, we're going to go over RC, but you get the point. We're going to go through a bunch of these commands, and but there's one that I haven't spoke about, or you need a refresher. Just type lsc, and then you can go look through and find the command that you need. Also, just another one thing I thought was cool is it literally has a pre-built command for ARP cache poisoning. So I mean, there's everything from very advanced all the way to very mundane here. So have a look before you get started, and if you forget something, it's super helpful for that. Okay, now Scapy, the way that it builds packets is it allows you to create headers and kind of stack them on top of each other. So, and you'll kind of see what I mean as we go, but so one of the most common, or so I'll show you the most common ones here, but there's the ether, or basically the layer 2 header. So you can see all of the different attributes with the show function. So you have the Ethernet, the destination, the source, and the type. So again, those are all fields that you could access and alter with or through the Ethernet object, or I guess, yeah, I think object would be the correct way to say that. Okay, now I'm just going to show you a couple more of the big ones just to get an idea of what we're looking for. So we'll say the IP header, you can do the same thing and show. We have access to time to live, the protocol, the checksum, the source, the destination, all these good things, which can be modified and updated to suit your needs. Just going to show two more. TCP. So again, source port, destination port, ACK flag, 6 flag, checksum. So again, you have access to all of those. And then UDP, source port, destination port, checksum. So basically, it's just going to build out. And so let's just say that you had an empty IP, empty ETH header, TCP header, UDP header. You stacked all three of those, or an ETH, IP, and TCP, say, on top of each other with nothing altered. It would just automatically generate what it thinks the best fit is for you, and it'll have a kind of a generic packet that you can send out. So really cool thing. So basically, whatever you don't specify, Scapy will fill in for you. So it'll make the packet work, which is awesome. So you do this if you've ever done this any other way, making sure you have exactly the right number of bits and everything's filled up correctly is pretty tough. especially the checksums. The checksums are always, in my experience, these have been the worst for me to calculate and make sure those are always correct, so that your packets don't get dropped. So anyway, some really nice functionality here, and kind of a neat idea of just stacking the headers on top of each other. As we go, it'll make more sense. So okay, so now, all right, cool, Spence, all this stuff about headers. Now what do we do with it? So we'll start sending some packets. So let's send an IP packet, okay, and we want it to go to some random IP address on our subnet. So let's say Cisco 168.1.53. I don't think there's anything on 53. Okay, now before I send this, I'm going to go filter in Wireshark. So there we go. We're going to filter, and ideally what we should see is when we send this packet, it should just be a generic packet that should be sent, and we should see it here. So let's go ahead and check that out. All right, cool. So there we go. So one randomly generated IP packet. And if we inspect it, we see that it's just broadcasted out. The source is my Mac. And then down here, it just took auto filled in the IP address of my computer or associated with this MAC address, and then added in the destination that I wanted. So there you go, and it auto-filled all the rest of the stuff in. So pretty cool. But now let's say, what if I wanted to send more than one packet? Turns out you can do that too. So let's just send 5 packets now. And there we go. It's very slow today. There's one thing, I don't know why it's this slow, but you get the idea, right? So now we sent 5 packets. Okay, but maybe let's get more complicated. So, and also I don't want to have to type in or create the packet in the send function every time. What if I want to keep using a packet? So how can we store it? Well, we can just set it x equals to the packet. And actually, I tried this command earlier, it didn't work, and so I tried to spoof the Ethernet address, and it didn't like it because the ETH was not, or the MAC was not corresponding to the IP address, so it dropped the packet. So what we're gonna do is we're just gonna take an IP. We're gonna make an IP header with a source and destination. Okay, and then we're gonna stack that on a UDP header. I can probably just copy this faster. So we'll stack it on a UDP header, and we'll copy that in there. Okay, and then we'll just hit enter. Okay, and then we'll do x.show, and that'll show us the specifications of the packet that we just created. Okay, so there we go. So now we need to change our filter because the IP address, the unique IP address is now 1.2. So let's send this packet. Let's see if we can get this packet to register. Oh, sorry. There we go. There we go. So 1 packet. All right, what if I want to send, just to double check here because I was a little bit late. We'll send 5 packets just to make sure that wasn't a fluke. And there we go. 5 packets. And let's inspect one of them just to make sure that all the information is correct. So there we go. There's our UDP. So we've stacked the IP on the UDP. And source port 53, destination port 443. Cool. And I chose these because this is the default for UDP, and this is the default for HTTPS. And what eventually what we're going to try to build to here is we want to create a DNS forwarder and we want to do it over DoH. So this is going to be important to us later. Okay. So I think you guys kind of get the idea about sending packets. So now let's go the opposite way. Now let's go down and let's look at sniffing packets. So say that I want to capture all traffic indefinitely. What I can do is I can just do sniff show, and it's going to capture packets for as long as I let the command continue. And then when I want to stop it, I can hit Control C, and these are all the packets that it's sniffed at that time. It's just going to push them to the console, and it's going to allow us to basically get a summary of what happened during that time. Okay. So now, what if we don't want all of that traffic? What if we only want a little piece of it, right? So as you may have guessed, we can sniff just a couple. So we can sniff, let's say, 5 packets. And again, we can also save them to a variable. So we can sniff 5 packets, save them to caps, it's our variable. And then we can do, let's do caps.summary. And that's going to spit us out a summary of all the packets that we just collected. So all of our packets were TCP packets, and it's telling us where they came from, where they're going, all this other good stuff. So, but what if we only want so we have 5 packets. What if we only want the first packet? So we can say caps.1, and it stores them in an array or a list or however you want to think about it. So we can call the first instance, or the first packet instance, and we can show that packet. And there we go. So that's what the full packet looks like that we just captured on the air. So destination MAC, source MAC, TTL came from, or it's going to my computer, coming from some other computer on the subnet or some other device on the subnet, and you know, yada yada yada. You get the idea, with some payload. So that's really the only thing we haven't done, is we haven't put a payload on top of TCP yet, which we'll do that in Python because it's just a little bit easier. It gets pretty clunky on the command line if we try to do it. So okay, so there we go. But now what if we want to filter, or if we want to be a little more specific with the packets we collect? So let's try to only get TCP packets. So we can filter by protocol. So we can say TCP, and you could say something like port 80 if you wanted to, but we won't get that crazy. But I mean, you can have conjunctions and other things there to make the filter more complicated. But for this situation, we're gonna sniff TCP, and we're gonna store it as, let's say, C2 for capture 2, and then we're gonna make this a count of 5 again. Gave me this error earlier. I don't remember why it gave me this error. Give me 1 sec, guys. I'm gonna check on that. Okay, guys, sorry about that. I figured out what was going on. So recently, I uninstalled Scapy and reinstalled it, and when I did that, I also uninstalled a library called libpcap. So I'll write that here. But basically, the fix for this would be to, if you're on Mac, would be to brew install a libpcap. I'm not going to run it now because I'm in Scapy, but just open a new terminal, run this command, install libpcap, and then you can go into the configs of Scapy by typing conf, And if you notice here, so before use BPF was true and use PCAP was false. This is really, I think, designed for Linux because the default, I believe, is TCP dump, which corresponds to BPF. But anyway, so what you have to do is if you're going to use Python on Mac, for example, you need to have this other PCAP library, libcap, installed, and then you need to disable this and enable this before it will work. So just heads up on that. I'm actually kind of glad we had that error, so that way it hopefully will save you guys some time. All right, so now that we've got that out of the way, I was showing you guys the filtering function. So now let's see. All right, so filter equals TCP, and there we go. So there we go. We're just gonna sniff for a little bit, and then I'm gonna cancel. And there we go. Okay, so TCP, there were 6 of them. But now let's actually say that so we can look at those packets. So we'll say temp equals sniff at TCP. And then just a second, we'll cut it off. And then now we will do temp.summary. All right, cool. So we got 3 TCP packets. And then we can do, of course, temp of 1.show, and we can actually see everything about that particular packet. Okay. Okay. A couple more things here, guys. So there's sniff, and then you can just sniff on a particular interface. So for me, I only have one interface, but if you had multiple interfaces, you could sniff. Like for example, mine is ENO1 or ENO0 right now, but like I think my Ethernet, my hard cabled NIC is EN1, so I could sniff that if I wanted to. For me, it doesn't really matter. I'm not going to run this command, but for you, if you have different NICs and you have packets running on them, then you can certainly sniff on different interfaces. But I just wanted to make you aware that was a possibility. And then another really nifty one is, for example, this is called wrap cap or WRP cap, but I like to call it wrap cap. But basically, this is going to save your package you collect as a PCAP file. So we're going to just call it test, and then we're going to give it the variable we saved. So we just saved all of these files as temp. So we're going to save these TCP, and we'll just say this is the TCP. Yeah, TCP. There we go. Excuse me. And we're going to save that. And then if we go here, there we go. You can see that that's a TCP. And I don't know why. I should have saved it as .pcap extension. So I'll just go ahead and do that really quick. .pcap. Yes, we want to add that. Come on, why didn't you add? So sorry, try that one more time. Oh, I said don't add. That's why. All right, and now we can open that in Wireshark, and we will stop and continue without saving. Let's go ahead and X out of that. So there we go. There's our 3 packets, and we can look at them in Wireshark and do whatever we need to do with them. Okay, cool. So now, and we don't really need Wireshark anymore, so I'm just going to leave that closed. But now, what if we want to read this into Scapy? Well, there's another command for that. And we're just going to call this read for reading into Scapy. And now we can say sniff. But this time, we want to do it offline. Offline equals, and then the name of the file. So this is tcp.pcap. Close parentheses. And now we should be able to see all of those packets in the PCAP. boom, same packets. So you guys kind of get the idea. You can save packets to PCAP files. You can read from PCAP files, analyze everything in Scapy. So a lot of really, really useful stuff here. And then finally, how do we visualize these packets? Because honestly, this kind of sucks. This is pretty good. But is there a better way? Or what if we want to look at just the bytes, the raw bytes, for example? So I'm just gonna think we called it temp, right? So I'm just gonna say this is gonna be equal to t, and I only want the first packet of temp. So there we go. We got t, and now I just want to. What if I want to see the raw bytes of this? So if you say raw of 1, or raw of t, that's going to give you the raw bytes associated with this file. And that's useful, for example, like if you wanted to pipe this into a packet as a payload, or maybe do it with a curl command or something like this. This might be useful. And then we can also call Hex Dump, and then on the same thing. And this is going to be a little more organized version. So something a lot along the lines of like what you'd see in Wireshark. And just as a note, this does not actually return anything. This only prints to console. I thought this returned, and I couldn't figure out why I wasn't getting bytes, and I realized it was because it just was printing to the screen. So this only prints the bytes to the screen. ls is another pretty useful one. So for example, if we do ls of t, it's going to give us all of the fields, the header fields, all nice and organized. And then it's going to tell us exactly what each one of those is. So that's pretty nice. And then finally, we've already been over packet.show, so I'm not going to go over that one. And finally, the moment you guys have all been waiting for is all those fancy visualizations that we installed so much stuff for. So this is one of them. This is PS dump. And it should, there we go. All right, cool. So it's going to generate us a PDF of this T packet that we just generated. So it's going to tell us all about it, all of the headers, even the raw load, and it's going to map or track each of those to its corresponding bytes. So this is actually pretty nice. I actually really like this. I don't know if it's quite as good as Wireshark, to be honest, but I like the fact that it outputs to a real savable file. I really like that. So it could be good for like papers or reports, or I could see this actually being really good for academia if you are writing a paper on networking or anything of that sort. This would be really nice. So, and then let's see. This is the same one. I mean, I think they're technically different, but I don't really notice any difference between them. This is also going to generate pretty much the same thing. So yeah, I mean, it's still a PDF. I think maybe one might be better quality than the other, but other than that, I'm not really sure what the difference is. But either way, you can use either one of these commands, and it will output a PDF style, almost Wireshark-like rendition of what the packet actually looks like. So pretty cool. I think it's worth the extra effort for that. I think it will come in handy down the road. And then finally, we have this command called .command, which will basically do the inverse. So we entered a command to get the packet, and now we're going to enter a packet to get the command. So I actually haven't used this yet, so I'm curious to see what it outputs. So I guess interesting. So it just spits out everything that all of these fields that you need. Yeah, so I guess you could enter this command and then just build the packet right off of this. So this is actually pretty cool. So if you are confused on how to make a packet, you could find a packet like the one that you want, and you could use this command and kind of back calculate, for example, to see how you could generate these type of packets in the future. So that's actually a very useful command, and I'm glad that I tried that. Okay, this video went way longer than I wanted to, guys. I do apologize, but I hope you got some good stuff from it. I think a lot of these commands are super useful, and I think there's a lot you can do from the command line. In the next video, we'll look at what we can do from Python, and the functionality and the scalability goes up a lot once we get into Python. So anyway, guys, I'll see you in the next video. Thank you so much for watching. If you like the content, please give me a like and subscribe so I continue to grow and produce better and better content for you guys. And also, if you really enjoy the content, you might even consider buying me a coffee, and the information for that is in the link in the video description. But if you don't want to do either of those things, just please give me some feedback in the comments and let me know how I'm doing, if anything's unclear or you're confused about anything, or if there's anything I can improve on. But guys, thanks again. Have a great rest of your day, and I'll see you in the next video.